Okay, so this is the project part of the project where you are going to write your composite function. So remember, my graph was translated, then dilated, then rotated, and then reflected. Okay, so there's two ways I can actually write this transformation. All right, so I'm going to actually write it in both ways for you, and you can choose whichever way you want to turn in for your project. Okay, so I'm just going to write over here again what order it went in. So I was translated first, did a translation first, then I did a dilation next. All right, so this was one, this is two, then I did a rotation, and then I did a reflection. So let's write the rule. Let's go ahead and be clear that my translation was -2, 3. My dilation was a third. My rotation was 180 degrees. And my reflection was y equals -x. Okay, so now I'm ready to write my rule. Again, there are two ways to do it. So here's the first way. Remember that composite functions are worked from right to left. Ooh, did you hear that? They're worked from right to left. Composite functions are worked from right to left, right? So that's the opposite of how you read a book. That is the opposite of how you read a book. So that means my translation is going to go over here to the right because it was the first one. So -2, 3, okay, like so. And I am going to put x, y at the end here. Then I'm going to do the circle. That circle means composite. And then I'm going to put the dilation, which came next. So dilation, and my subscript is 1/3. Then I'm going to do another circle, and I'm going to do my rotation. So my rotation was 180 degrees. And that, remember, that circle means composite. And so then I'm going to do another circle, and I'm going to do reflection, which is a lowercase r, and y equals -x in my subscript. So that's how I write my function, my composite function. All right, so that's one way to write it. The other way to write it, and so you would close it off with parentheses here and here, and don't forget this part, the x comma y there. All right, so another way to write this function is to write it with successive parentheses. So reflection will go here, then rotation will go right there, okay, then dilation will go right here, then translation will go right there, and then your xy will go right here. And then you would need to close all of these parentheses, right? So I had a parenthesis to close the xy, I have a parenthesis to close the t, I have a parenthesis to close the d, I have a parenthesis to close the r, and I have a parenthesis to close the lowercase r. So those are the two ways you can write your composite function. All right, I'm glad we were able to get that.